Hey folks, this is the first assignment for Chapter 10. Let's dive in. Number one is talking about Toyotas versus Nissans, which owners are more satisfied with the cars. Um, and they just had a sample of Toyota owners and Nissan owners, and they asked them, would you say you are satisfied with your car? Is this about comparing means or proportions? Since this is collecting counts, this means it's proportions. Because our data would be, out of 400. So like the proportion of people that the Nissan owners that would say they're satisfied, let's say it's 280. Well, that's a proportion. You know, your count is 280. What type of study? It's talking observational versus an experiment. Since they did not apply a treatment of any kind, this is an observational study. They simply asked people how happy they are with the car they own. They didn't make them drive a certain car. They didn't do anything like that. Number three, this one's about computer game players and the high scores that they earn. When someone presents them a cheer, when someone is present to cheer them on when they play alone. So 50 teenagers who are experienced at playing the game, they volunteered for the study. They randomly assigned 25 of them to play alone, and then 25 playing alone, and the other 25 played with a supporter, someone who cheered them on, and then their score was recorded. So what kind of problem is this? This is a sample means problem because they have a raw score. You know, I don't know what the score is out of. Maybe the high score is 20. I have no idea. So it's an average. It's not a percent. It's a sample mean. What type of study is this? This is a random experiment. Why this is kind of a flashback to earlier in the year because a treatment was imposed. What is the treatment? Um, it was imposed to half the people. The treatment was the supporter, the person that was cheering them on, right? The treatment was someone standing in the room, sitting in the room, watching them, going, "Yeah, you're doing well." Okay. Number seven. Up here are the directions. Explain why the conditions for using a two sample Z procedure are not met, okay, in these following exercises. So number 7 is about a movie called Civil Action, came out in 1998. It tells the story of a legal battle that took place in the small town of Woburn, Massachusetts. A town well-supplied water to the residents was contaminated by chemicals, and during the period, the residents drank from the well. 16 of the 414 babies during that time had birth defects. Very, very sad. On the west side, on the west side of Woburn, 3 of the 224 babies born had birth defects. Okay. Um, so there's two groups. There's the eastern side and the western side. So the conditions are random. Is it approximately normal and independent? And the thing here is that it was not random for number 7. Oh wait, no, sorry, I lied. Um, the large counts is not met. It's no, remember what this means is you need at least 10 successes and 10 failures from each group, from the eastern side and from the western side. Okay, the western side, western suburbs, or just say the western side, only had 3 babies with birth defects. So um, to be approximately normal, that number needs to be at least 10. The other 3 numbers were all okay. The other numbers would be 16. I gotta do some math. 414 minus 16 would be 398. Um, and then the last number would be 228 minus 3, so that's 225. So all of these are greater than or equal to 10. So I'm good with these three. The only one that is too small is that. And when large counts is not met, the normal condition is not met. So we can't know for sure that the data would be normally distributed. Okay. Number 9. Back to 7. I think you could also say that it was not random. Maybe you were thinking that too. And that's what I started to say at the beginning, but because they did not pick a random group. They actually just picked um, everybody from the eastern side and everybody from the western side that had babies during that time period. Um, Not entirely random. Number 9, there's investigating fire being a threat to shrubs in dry climates. Some shrubs can resprout from their roots after their tops are destroyed. One study of resprouting took place in a dry area of Mexico. Um, Here it says randomly assigned, so we're good with random. But once again, the normal condition will not be met. Um, uh, Condition is not met because of large counts again. It says they burned some stumps with a propane torch. Okay. They had a treatment group and they had a control group. All 12 of the shrubs in the treatment group resprouted. You might be thinking, well, that's great. Well, that's 12 successes, and that's good, but it's only 0 failures. And that is not good. In the other group, um, 8 of the 12 in the control group resprouted. So you had 8 successes again. That is not big enough. And you had 4 failures, 4 that did not resprout. So those are the 4 numbers you need to look at, and 3 of them are too small. So it cannot be stated that it is approximately normal. Number 11, do younger people use online instant messaging more than older people? Random sample of IM users found that result in a sample of age 18 to 27-year-olds. Sorry. In a sample, these ages, they said they use instant messenger more than email. In the group of older 28 to 39-year-olds, 26 of the 143 people used IM more than email. So there's your 2 samples, okay? Your samples are people of 2 different age groups. We're going to make an interval. We could chat through the conditions real quick. It said it was random. Do we have at least 10 successes and 10 failures? We had 73 successes here. We had 26 successes here. If I do 158 minus 73, that's going to be bigger than 10. If I do 143 minus 26, that's my failure, so to speak. That will be bigger than 10. Independence, is 158 people less than 10% of all people in this age group? Yes. Is 143 less than 10% of everybody in the age of 28 to 39? Yes. So the conditions are met. You do have 2 proportions. P1 would be 73 out of 158. P2 would be 26 of 143, okay? And we're wondering if the younger people use it more. So maybe I could do this to help you change this to PY for younger and PO for older. So we're wondering if we're kind of getting a little further than we need to, but is PY greater than PO? In other words, if I do PY minus PO, will that be greater than 0? That's the question, okay? I'm kind of, this may be more than you need to do because you just have to create the interval. But I'm going to use my calculator button now to save time, um, and you can too. So here you go to Stat, Tests, and the button for this is capital B, to prop for proportion, Z interval. When you click on this, you just have to put in the numbers that I just had listed, right? And in the younger group, 73 and out of 158, use IM more than email. And in the older group, it's 26 out of 143. And what was I forgot, what was the level of confidence? It was a 90% level of confidence. So when in doubt, I'm just going to encourage you to use the calculator for this, you guys. So it produces the interval for you right there on the top. It even shows you the two proportions are 46% and 18%, which is a huge disparity, huge difference. Okay. Um, so then we would write down, we are 90% confident that the true difference in proportion of, we'll say young, I know there's an age range, of young people who use IM more than email um, compared to old people. That's very wordy. Is between blank and blank. And if you have those numbers up on your calculator still, you can round it to 0.19, I don't know, 59 and 0.3461. So it didn't really say to interpret it up here in the directions, but hey, it can never hurt to practice, okay? 12 is listening to rap music. They're asking if young black people listen to rap music more than young white people. Um, it says, it gives you the results of the survey, construct and interpret the interval. So again, let's do this. PB, proportion of the young blacks that listen to it. What was that? So if you keep reading, it would be 368 over 634. This goes with this. And then in the group of the young whites, 567 and 130. So these are the two proportions that we are given from our sample. You could find both of them if you needed to. Again, it was a random sample. It says random. And you have at least 10 successes and failures in both groups. You could say it's also independent. Plugging in the numbers into the calculator, stat, tests. When in doubt, you guys use the calculator. Okay, see if I get these numbers right. Okay, we had 368 out of 567 for the young blacks, and then the young whites had 130 successes. Oh, wait, sorry, had that wrong up here. 634 there and 567. So the sample of the young blacks was a larger sample size. And that's okay. The sample sizes don't have to be identical. And I forgot what proportion. We're doing 95% this time. So there you go. About 29% to 40%. Okay, so we would say we are 95% confident. The difference in proportion of, of young blacks who listen to rap music than young whites is between, it's very wordy there, especially that middle part, is between what and what. So we had 0.29, 0.299 and 0.403. Um, there you go. Let me wrestle with this one for a little while too. If you wanted to actually write out the work, okay, um, I would actually like find these proportions. So like this purple one for the young blacks was 0.58, and then minus this green one for the young whites is 0.229. Then you do plus or minus your z-score for 95%. Remember, that's 1.96. And then you've got your square root, and then you've got like your purple numbers. So the you're finding the standard error for the young black sample, 0.58, 1 minus 0.58, and then you divide here by the sample size of that group, that was 634. And then you repeat that again for the young whites, so that's the green number, 0.229, 1 minus 0.229, over the sample size of the young whites, which was 567. Okay, I'm just showing you how to write it out. I would do this, I would write this out if I had an FRQ, and then I would revert to the calculator button. You would need to show this to show understanding of the formula and the process, but then use the calculator button to actually produce this. All right, 13. Um, a surprising number of young adults ages 19 to 25 still live with their parents. Oh my goodness. A random sample by the National Institutes of Health included a bunch of men and a bunch of women in that age group. Their survey found this many men and this many women still live with their parents. So we're comparing who who takes longer to move out, I guess, men or women. What is the difference in the population proportions? And then it tells you here, ooh, men minus women. Okay. Um, so let's do this again. I like to label my proportions. Proportion M, proportion of men that they were still living with their parents, and this was 986 over 2253. Okay. And that is about 0.438 if you divide that. Then if you do that again for the women, PW, that's these two numbers. So we got 923 over 2629. That is 0.351. So at the outset, it looks to me like more of the men, the young men, are still living at home than the young women. Okay. We are doing men minus women. Okay. So if I were to try to write out the entire interval, it would be well, I can color code it again. 0.438 minus the women, 0.351, plus or minus the Z, which I usually make red. We're doing 99%, which is 2.576. If you remember that, you can look that up. That's the Z star that you can look up on the green packet. And the square root of a bunch of stuff. The first part's the purple, the standard error of the sample of the men. And I'm just writing it out right now, you guys. I am not going to even remotely try to put this in my calculator because it looks like a disaster. It looks like I would never be able to do that correctly. You can try it. Maybe you like challenges. And then the green part is the standard error for the women. 1 minus 0.351. divided by the sample size for the women, which was 2629. Okay, I'm just setting it up. If I were to tackle this on the calculator, I would start here and get that number, and then I'd work my way to the left. And I'll probably go through that in class. But what I would really encourage you to do is to use the calculator to produce the interval for you. So again, this is capital B. Let's see, what did I have again? 986 over 2253, that was the men, and then 923 over 2629 for the women, and we're doing 99%. Whoop. And there you have it. And I believe when you do this, by the way, you may be wondering, will this do men minus women or women minus men? It will always take P1 minus P2 when you input it into the calculator like this. So my P1 was the data for the men, and my P2 was the data for the women. It always does 1 minus 2. So I get that interval on top, which is about 5% to 12%, roughly. Okay. It says interpret, so let's write down the sentence. We are 99% confident, quite confident, that the difference in proportion well, maybe word this one a little bit differently. Let me just say that the proportion of men still living at home, we'll say young men, because there was an age range with all of this, right? This was 19 to 25-year-olds. The proportion of young men still living at home minus the proportion of young women still living at home, young women, I should say, wrong emphasis on the wrong syllable, is between, and what do we have on the calculator there? It was about, if I remember it was like 0.051, and about 12%, if I remember. I think it was 1, 2, 3. Okay, so there's the interval. That's part A. Part B, does the interval give convincing evidence of a difference between these two population proportions? And it does, you guys, because so part B, like, think about this as a null. The null proportion would be that the proportion of men equals the proportion of women, which wouldn't that mean that the proportion of men minus the proportion of women would be 0, right? That would be the null. But 0 is in there, right? Or no, it's not in there. Sorry, 0 is not in there, right? 0 is not in the interval, not contained in the interval. So we have convincing evidence. And then which way do we have it? Do we have it that more men are staying home or more women are staying home? Well, the men's was larger. We have convincing evidence that more men, more young men are still living at home than women. Whoop. There we go. So again, I was really using the calculator today, guys, to speed this up a little bit. Hope that helps. See it.